Hi friends, today we are discussing about the local variable and global variable. Myself Pankaj Vanade. First we discuss on the local variables. What is the local variable? Local variable transform the data within a single VA and allow the data to be passed between the parallel loops. They also break the data flow programming paradigms. There are two ways to create the local variable. First, is right click on the object terminals and select the create and then local variable. A local variable icon for the object appears on the block diagram as shown in the figure. This is the figure where you see the create function and you select the local variable. Here is another process. Select the block diagram and then select the data communications, and here you will see the two variables. One is the local variables and another is the global variables. After this we will see the examples of the local variable. This is the example of the local variables by using the while loop. Here we use the random variables which number are 0 to 1s and create a indicator function. Another way to select the local variable from the structure palette. Create the front panels and select a local variable from the function palette and place it on the block diagram. The local variable node is not yet associated with the control or indicator. The local variables allows to upgrade a value. The local variable to associate with a control or indicator. Right click the local variable node and select the item from the shortcut menu. Then the shortcut menu lists all the front panel objects that have earned labels. The lab uses earned labels to associate the local variables with the front panel objects. So they label the front panel of controls and indicators with the descriptive earned labels. Earned label becomes variable name and select whether you want to read or write to the local variables. Here is another example. Here is the second way to select the local variables or create a local variable from the structure palette. Here, go to the select item, then string in. As you see, after you create a local variable or global variables, you can read the data from a variable or write the data to it. By default, a new variable receives a data. This kind of variable works as an indicator and is a write local or global. When you write the new data to the local variable or global variable, the associated front panel control or indicator updates to the new data. You also configure a variable to behave as a data source or read local or global variable. Right click the variable and select change to read from the shortcut menu to configure the variable to behave as a control. When this node executes, the VI reads the data in the associated front panel control or indicator. Then initialize the local variable and global variable before reading them. To change the variable to receive data from the block diagram rather than provide the data. For this, right click the variable and select change to write from the shortcut menu. In the block diagram, you can distinguish the read locals or global from the write local or global. The same you distinguish the controls from the indicators. A read local or global has a thick border similar to a controller. A write local or global has a thin border similar to an indicator. Here you will see for read a thick border is there, and for write a local or global a thin border is there. When you write to a local variable, you update its corresponding front panel object, and when you read your local variable, you read the current value of its corresponding from the front panel object. This is all about the local variables. Now we will see the global variable. What is the global variable? The global variables are built in the LabVIEW objects. You can use the variables to access and pass the data among the several VIs that run simultaneously. A local variable shares the data within VI, but the global variables also share the data, but it shares the data with multiple VIs. In the global variables, multiple VI upgrade the value, but in the local variable, it allows upgrade one value. In the local variable, we have restrictions of only one VI, but in the global variables, we create a multiple VIs that run simultaneously. Suppose you have two VIs running simultaneously, which is shown in the examples. This is the example of the global variables. Here we use the sine wave, timer is there, boolean functions. This is we are using this by while loop. Here we use the two VIs. When you create a global variable, the LabVIEW automatically creates a special global VI which has a front panel but no block diagram. Add the controls and indicators to the front panel of the global VI to define the data types of the global variables. Select a global variable from the function palette and place it on the block diagram. Double click the global variable node to display the front panel of the global VI. Place the control indicators on these front panels. Place the controls and indicators on this front panel the same way you do on the standard front panels. LabVIEW uses the on labels to identify the global variables, so they label the front panel controls and indicators with the descriptive on labels. Figure shows a global variable front panels with a numerical string cluster containing a digital and boolean controls. This is the figure in which it shows the numerical string and the cluster values. This is the figure of global variable of the front panels. Now we will see one example of the global variable. We are using the while loop. First create a new VI Then create a global variable by right clicking on the block diagram, then data communication, and then global variables. Inside the global variables, take the slide, knob, stop button, and in the front panels, take a waveform chart. One timer is there. Select the while loop from the programming, then structure function. Select the waveform chart, then right click on this chart, go to the advanced and update the chart as a sweep chart. Connect the two global variables to waveform chart through the merge signal functions. Merge signal. What is the merge signal function? Merge signal, it merges the two or more signals into a single output. This function appears on the block diagram automatically when you wire a signal output to wire the branch of another signal. Input signal specifies the signal you want to combine with another signal. The combined signal returns the combined signals. Then result will display on the waveform chart. Save the VI and run the program. Here, this is the output on the waveform chart. On the front panel, here the slide is there. After you finishing placing the objects on the global VI front panel, save it and return to the block diagram of the original VI. You then must select which object in the global VI that you want to access. Right click the global variable node and select a front panel object from the select item shortcut menu. The shortcut menu lists all the front panel objects that you have on levels. If you want to use the global variable in other VI, then select the functions, click on the all functions and select a VI. By default, the global variable is associated with the first front panel object with an on label that you place in the global VI. Right click the global variable node you placed on the block diagram and select a front panel object from the select the shortcut menu. Now we will see the common problem occurs in the global variables and the local variables. There are the two common problems that the globals will cause in an applications. One is the rest condition and the second is the performance problem. These problems are pretty easy to diagnose and relatively easy to fix once you understand them. A rest condition occurs when more than one piece of code needs to update a global and there is no way to ensuring that they take turns and leave the global in a valid state. The solution is to control the access and making the code take turns. Now second, the performance problem. It is that it also possible to use the globals in ways that greatly slow down VI execution. The problem is that the global variables slow down your VI execution because we are using the multiple VI in one global variable. This is very different from the rest condition, in that the program executes correctly, but it takes longer time than it should to complete. There is a very good solution that will actually make the code easier to read. At the same time, it restores the performance. To speed this up, make a sub VI that takes the parameter for the indexing the global and return the data. The local variable and the global variables are advanced label concepts. They are inherently not part of the label data flow execution models. Block diagrams can become difficult to read when you use the local and global variables, so you should use them carefully. By using local variable, in the local variable we use only one VI, but in the global variables we use the multiple VI. This is the advantages of the global variables. This is all about the local variables and global variables. Thank you so much.